Okay, this lesson we'll be looking at combining transformations, part 1, from Unit 2, Chapter 1, Function Transformations. The focus in this lesson will be on, as you can see here, mapping rule, transformations, and functional form. Let's do a quick review, first of all the transformations that we've done. If we consider the base function to be y equals the f of x, our transform function looks like this. Now let's consider what all of these variables represent in terms of a transformation. The variable a right here represents a vertical stretch of a. The variable b represents a horizontal stretch of 1 over b. The variable h represents a horizontal translation of h. And the variable k represents a vertical translation of k units. Also worth noting here is that if we have a reflection in the x-axis, there will be a negative located inside the brackets here. If we have a reflection in the y-axis, there will be a negative located in front of the f of x. Also very important is your mapping rule for this function. The mapping rule will be xy maps to 1 over b, x plus h, ay plus k, ay plus k. Let's look at some examples, let's look at some examples of equations, and let's look at what the transformations are, and let's state the mapping rule as well for each of these. So let's start with the first example right here. Let's state the transformations first of all. The 2 here represents a vertical stretch of 2 units. The plus 3 represents a vertical translation of positive 3. You may see this equation written like this as well. 1/2 outside of y subtract 3 equals the f of x. The mapping rule for the function becomes xy maps to. There's no change in the x. We have a vertical stretch of 2, and we have a vertical translation of positive 3. There's the mapping rule for that function. Let's look at example number 2. Example number 2, there are 3 transformations here. The negative, located right here, represents a reflection in the x-axis. Reflection in the x. Let's write that down. The 1/3 represents a vertical stretch of 1/3, and the 6 represents a vertical translation of positive 6. These are the 3 transformations that are occurring here. 1, 2, 3. Sometimes you may see this equation written in transformational form, and it will be written like this. Negative 3 side of y subtract 6 equals the absolute value of x. That's what transformational form would look like. The mapping rule, of course, would look like this. xy maps to. Again, there's no transformation associated with the x. With the y, we've got a negative 1/3 y plus 6. Normally, I do this by looking at it in this form, but I can do it from either form. But I take the negative if I see it here. I take the reciprocal of the 3 to get a 1/3. I take the y subtract 6 and I call it y plus 6. Again, some of you may be getting it directly from this equation. That's fine as well. Let's look at this example here. Y equals the absolute value of 2x subtract 4 subtract 1. What's very important about this equation is that it is not completely written in the form we want it. We need to rewrite this equation as, let me do that over here actually. Let's rewrite it here as y equals the absolute value of 2 outside of x subtract 2 subtract 1. Now this particular function here, with the 2, you have to rewrite this function. The 2x subtract 4 is to be rewritten with a set of brackets. Very important that you do that. So I rewrite this 2 instead of x subtract 2, subtract 1. Now I have 3 transformations here. The first 2 that you see there represents a horizontal stretch of 1/2. I've got a horizontal translation of positive 2, and I've got a vertical translation of negative 1. Again, you may see the equation written in a different form. It would simply be y plus 1 equals the absolute value of 2 outside of x subtract 2. You may see it written in that form. The mapping rule would be xy maps to 1/2 x plus 2, y subtract 1. There's your mapping rule for that function. Example number 4. Again, notice the brackets here. I need to rewrite this with a set of brackets inside. I got y subtract 4 equals the f of negative outside of x plus 2. That must go there. It's important that you write it like that. Of course, if you want, you can bring the 4 over here as well and write it in the functional form so that it looks like this. Y equals the f of negative x plus 2 plus 4. Now let's list all the transformations that we see here. Transformations are, we've got a vertical translation of positive 4. We've got a reflection again, but this time it's in the y-axis. And we've got a horizontal translation of negative 2. Horizontal translation of negative 2, reflection in the y-axis, and a vertical translation of positive 4. Or again, if you want to look at this equation, it's a positive 4 vertical translation. Mapping rule, let's write the mapping rule for this function. xy maps to, I've got negative x subtract 2, y plus 4. Example number 5. Note the same thing again. The brackets must exist in here. We need to rewrite this equation so that the brackets exist right here. So it becomes negative y plus 5. Don't have a lot of room here for this, but let's see if we can squeeze it in here. Negative y plus 5 equals the f of negative 1/2 outside of x plus 8 bracket. Again, look at this and ensure that it's the same. Negative 1/2 times x is a negative 1/2 x. Negative 1/2 times 8 is a negative 4. This is now written in transformational form. Again, you may see it written in functional form, and if you did, it would look like this. Y equals negative f of negative 1/2 x plus 8 subtract 5. That's the other way that equation will be written. Now, let's state all the transformations again. Number of transformations here. We have a reflection. This time in both axes, because you can tell by the negative located right here and the negative located right here will represent a reflection in both axes. We have a vertical translation of negative 5. We have a horizontal translation of negative 8. And finally, we got a horizontal stretch of 2. And there are all of our transformations. Now, let's write the mapping rule for the transformations. The mapping rule will look like, actually, I think I've made an error here. In fact, I have made an error. I need to go back and correct it. Just as I need a set of brackets here, I also need a set of brackets here. This is not written correctly in functional form. sorry, in transformational form. It really should be written like this. Let me rewrite it, please. The negative actually has to be removed as a common factor as well. Luckily, I picked up on that error. Let me fix this here. It's negative outside of y subtract 5. That's better. Negative outside of y subtract 5. Now let's look at our reflections again. Make sure we're good here. We've got a reflection of both axes. That's still fine. The vertical translation is actually positive 5, not negative 5. Vertical translation is positive 5. Horizontal translation is negative 8. And the horizontal stretch is 2. So now we're good. The equation that I've written over here, of course, should be, let's see if we're good with that. Yes, it should be a plus 5 there as well, right? That should also be a plus 5 here. Because again, it's a negative 5 there. When it comes over, it becomes a plus 5. I divide through by negative 1, then I bring the 5 over, and it would look like this. Okay, just sort of doing a couple of steps in my head there. This is correct. Okay, XY maps 2. We've got a negative 2, x subtract 8, negative y plus 5. Here we go. So there's the mapping rule for that function. One left here. We've got negative 1/4 y is fine. Again, note another example whereby the 3 has to be removed, and we end up with this as my equation. Negative 1/4 y equals 3 outside of x subtract 3. Very important that you have a set of brackets located here and here if required. Here is not required because there's nothing in front of the y. Here there's a negative 1 in front of the y. I need to remove the negative 1 as a common factor. Very important. Okay, list all of our transformations here. We've got a reflection again. We use a different color here. A second. We've got a reflection. This time in the x-axis. And we have a vertical stretch of 4 units. Again, some of you may be wanting to think about it in the other form, which would look like this. Negative 4, bracket, 3x subtract 3 squared. In this particular case, you just need to remember that the base function is actually y equals x squared. Okay, the squared has nothing to do with the transformation. The base function is y equals x squared. I got a vertical stretch of 4. And we have a horizontal stretch of 1/3 because of this 3 right here. And we also have a horizontal translation of positive 3. Let's write our mapping rule. XY maps 2. We have 1/3 x plus 3 negative 4 y. There's our mapping rule. Okay, let's look at some examples here. Again, most of these examples we'll do here now will involve multiple choice. It might be a good idea for you to pause the recording and see if you can do these on your own. Which statement is true when the graph of y equals the f of x is transformed onto this function? Again, we're looking for the transformations. Notice again, no set of brackets here. We need to rewrite this function like this. Or rewrite the equation as negative 1/3 outside of x subtract 18 bracket. Make sure we're good. Negative 1/3 times x is a negative 1/3 x. Negative 1/3 times a negative 18 is a positive 6. There is my equation. I can see here that I've got a horizontal stretch of 3. And I've got a horizontal translation of positive 18, and I also have a reflection in the y-axis. Okay, we're looking for one of those answers to be correct here. Horizontal stretch of 1/3? No. So it's got to be either B or D. Horizontal stretch of 3, horizontal translation of 6, horizontal stretch of 3, horizontal translation of 18 units to the right, which is positive, so the correct answer is indeed D. Example 2. Which equations results when the function f of x equals the absolute value of x is reflected in the x-axis, vertically stretched by a factor of 1/3, and translate it 4 units to the left. Reflection in the x-axis will occur when we get a negative in front of the y, or the f of x. And of course, that's the same if the negative is over here. So every one of these, if you look at them, they all have the negative located here, which all represent a reflection in the x-axis. So that's not going to help us, because they all have a reflection in the x-axis. It's vertically stretched by a factor of 1/3. There are 2 of these that got a vertical stretch of 1/3, and that's A and C. And we're looking for a translation of 4 units to the left. That's a horizontal translation of -4. A horizontal translation of -4 would be A. Horizontal translation of -4 is indicated right there. This one has a vertical translation of -4. So the correct answer is A. Example 3. The mapping rule, xy maps to 2x subtract 4y plus 3, is applied to this function. What is the equation of the resulting function? So now we're trying to match our mapping rule with our function. Again, remember that you got to have a set of brackets here, 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 or here. I'd have to actually would have to rewrite all of these with a set of brackets. So let's do that. And I would have y equals the f of 2 outside of x subtract 2 bracket plus 3. If you want to write the transformational form, it would be y subtract 3 equals the f of 2 outside of x subtract 2. Let's just check and see if that one is correct. 2x subtract 4? No. 2x subtract 4 is not going to work for us, because it's going to be 2x plus 2 here is going to be the mapping rule for this function. 2x plus 2 is not what we have, so I know this one doesn't work. Therefore, this one's not going to work. It has to be either C or D, because both of them got the same thing here. Okay, let's rewrite this one here in the correct form. It's 1/2 outside of x plus 4 subtract 3. Bring the 3 over if we want to put it in transformational form. And again, some may want that and some may not. But because it was probably taught to students both ways, I will do both. Okay, here's the equation written in transformational form. And I'm looking for this mapping rule. 2x subtract 4, that's looking good there. 2x subtract 4. Y plus 3. Y plus 3, no. If you look at this one or this one, depending on the form you're used to seeing, y plus 3 is not correct. So the correct answer has to be D. No other choice but to be D. And you can see that that would work out fine, because we already knew that this part here was fine, and the plus 3 here gives us a vertical translation of 3 units, and that's exactly what we have here. So the correct answer is indeed D. Example number 4. If y equals the f of x, which mapping rule will be used to produce this function? So now again, we got our function, looking for the mapping rule. Again, we want to rewrite this function. Y equals -2 f of. Notice most of these do not put that set of brackets in there. We got to put them there. -3 outside of x subtract. Removing -3 as a common factor. So x subtract 2, subtract 4. Now some of you, again, can look at the equation in that form and get the mapping rule. Others may want to see it in transformational form. So I bring the 4 over. And I divide both sides by -1/2. From there, we should be able to identify, whether you look at the equation here or here, doesn't matter, you should be able to identify the correct mapping rule. The correct mapping rule is going to be, let's find it here, it's going to be -1/3 x plus 2, -1/3 x plus 2, it's the only one there with that, and it's going to be -2y subtract 4. Correct answer is clearly C. Clearly C. negative 1/3 x plus 2, and a negative 2y subtract 4. Example 5. What is a horizontal translation for the function that you see here compared to the graph of, or compared to the function y equals the f of x? All we're looking for is the horizontal translation here. So again, we need to rewrite this here as the f of 2/3 outside of x subtract what number will give me 8. So again, think about what I just said. 2/3 times what number will give me 8. So let's write that out. If we're not quite sure how to do this, let's write it exactly what I said, because we know that we removed the common factor of 2/3. So 2/3 times what number, let's call it p, equals 8. 2/3 times what number equals 8? That's what I'm trying to figure out here. So of course, to figure out what p is, I simply need to multiply both sides by 3/2. 3/2 times 2/3 will give me p equals 24/2, which is 12. So p equals 12. That's the value that needs to go in right there. And we can easily check. 2/3 times 12 is 24 divided by 3 is indeed 8. So the horizontal translation is positive 12. Correct answer is D. Example 6, which is equivalent to that equation there. So now what we're doing is we're going to rewrite that equation in what we were talking about, transformational form. Now let's write it correctly. We're going to simply bring the 5 over first and write y subtract 5 equals negative 4 times the f of, now again we need to remove the 3 as a common factor, x subtract 6. All we need to do now is get rid of the negative 4, multiply both sides by negative 1/4, and that will do that. Negative 1/4 outside of y subtract 5 equals the f of 3 outside of x subtract 6. Let's find that equation there. Negative 1/4, y subtract 5, f of 3 of x subtract 6. Answer C. I think we have one more example left. Here it is. If a, b is a point on the graph of y equals the f of x, which point is on the graph of this function right here? Y subtract 4 equals the f of negative x plus 1. Again, what I would do is I would create a mapping rule for that function and plug in the point A, B into that mapping rule. If we want to create a mapping rule for that function, again, we need to make sure we got it written correctly. It's y subtract 4 equals the f of, that negative has to be removed as a common factor. It's negative 1 outside of x subtract 1. Very important that it is removed. Now the mapping rule will become xy maps to negative x plus 1, y plus 4. So there's my mapping rule. Let me just move this here down. And let's plug in the point AB into that mapping rule and see where it is mapped onto. The point AB, when plugged in, will become negative A plus 1, B plus 4. Negative A plus 1, B plus 4. Correct answer is B. Note in almost every one of those examples, I had to rewrite what was in the set of brackets here by removing a common factor. Even if there's a negative in front of the x, I need to remove that as a common factor of negative 1. I didn't see an example like it, so I will mention it. But even if you had something like this on the right-hand side, okay, if you had something like 2y plus 8 equals something, you again need to rewrite that as 2 inside of y plus 4. So if you were to see an equation written like that, just remember you do need to remove a common factor of 2 in this case as well. Okay, I think that ends the lesson. Let's have a quick look at the key ideas before we clue up. Okay, we can write the function in this particular form to better identify the transformations. Again, some of you may prefer this form, some may actually prefer transformational form. I leave that up to you guys, whatever you're used to being taught there, and I tried to cover both forms. Stretches and reflections may be performed in any order before translations. The parameters a, b, h, and k in that function correspond to the following transformations. A again corresponds to the vertical stretch. If A is less than 0, we know there's a reflection of the x-axis. B corresponds to the horizontal stretch. If B is less than 0, we know there's a reflection of the y-axis. H corresponds to the horizontal translation, and K corresponds to the vertical translation. And that ends that lesson.